All right, so we're going to be talking about solving one-step equations, okay? And before we go to this page, I'm actually going to scroll down and we're going to look at this, okay? So the first thing that I want to talk about is inverse operations, okay? Inverse operations. Now, you guys all know what operations are. We've been using them: addition, subtraction, multiplication, and division. Okay, these are all the operations. And inverse operations, well, when we break down the word inverse, we're talking about the opposite. Okay, they undo each other, it reverses what the previous one has done. Okay, or another word that you might hear is it undoes. Okay, in this case they wrote undo, but it undoes what the previous option did. Okay, for instance, we would use addition to undo subtraction. Okay, now you might say, well, Mr. P, what do you mean we use addition to undo subtraction? Well, let's say I had 5 minus 2. Well, what's 5 minus 2? Okay, well, it's 3, right? Well, if I want to get back to having 5, how do you undo the subtraction of 2? You add 2, right? Okay, so if I do 5 minus 2, we know that's 3, right? If I add 2, does that get me back to 5? Yeah, so this addition of 2 undid this subtraction by 2. It's the opposite, right? And vice versa, we use subtraction to undo addition. Okay, and vice versa, we use subtraction to undo addition. Okay, in our same example here, I could start out with 5 plus 2, and if I want to undo adding 2, I would have to subtract 2, right? 5 plus 2 is 7, and if I want to get back to 5, I do the opposite, which is subtract 2, and that gives me 5, okay? So subtraction undoes the addition, okay? Now, the other two operations that we want to feel comfortable with is we use division to undo multiplication. Multiplication. And that should make sense, okay? So if let's take a different example here. And let's say I had, 15, and we divided that by 3. Well, we know 15 divided by 3 is going to get us to 5, right? So how do we undo this division by 3? Well, we multiply, right? So if I divide by 3 and then multiply that by 3, won't that get me back to 15? Well, let's check. So remember, in order of operations, we always do multiplication and division from left to right. Well, the first thing I see is division. 15 divided by 3 is 5, and then I have 5 times 3, correct? 5 times 3 is 15. So notice this division of 3 and multiplication of 3 undo each other, okay? So we use division to undo multiplication, and we use multiplication to undo division. Okay, those guys are opposites of each other. Okay, now let's go back up here and take that and use what we have learned to help us with the next part, which is talking about properties of equality. Now we're going to add to the properties of equality later on when we get into algebraic proofs, but it doesn't hurt to have a general understanding now. Okay, now the addition property of equality, what that says is we can blank the same number to each side of an equation produces an blank equation. Okay, we can add the same number to each side of an equation. Okay, well, what's an equation? Well, an equation are all these guys, right? So that says I can add the same thing to both sides, and that produces an equivalent or an equal equation. Okay, I'm going to use the word equivalent. Okay, we can produce an equivalent equation. Okay, it's the same thing. Okay, we can add the same number to each side of an equation and produce an equivalent equation. It's the same thing. Okay, think in terms of a balance. Okay, you guys know a balance. If we have weights on both sides and it's balanced, it's equal on both ends. If I add the same amount to both sides, doesn't it remain equal? Yes, okay? So that's what the addition property of equality says. We can add the same thing to both sides. So what do you think subtraction is? Well, we can subtract the same number. We can subtract the same number to each side of an equation and produces an equivalent equation. Okay, so it produces an equivalent equation. Okay, so we can subtract the same number from both sides. Let's go back to that balance idea. If I have weights on both ends and we have balance, if I take away the same amount from both sides, do I maintain balance? Yes. Okay, so we can subtract the same number from both sides. Okay, then the division property of equality and multiplication property of equality, you guessed it, we can divide the same thing from both sides and we can multiply the same number to both sides. Okay, so the division property of equality says we can divide the same number to each side of an equation and it produces an equivalent equation. In other words, we maintain balance. And the multiplication property of equality says we can multiply the same number to each side of an equation and we maintain equality, okay, or we have an equivalent equation. Okay, we maintain equality. Okay, so with that in mind, we're going to use that to help us solve one-step equations. Now you might be asking yourself, why do they call it one-step equations? Because it takes one step to solve them. So what we have here is we have an equation we have constants and we have a variable. Our goal is to be able to get the variable by itself. We want to isolate this variable by using these inverse operations and applying these properties to get it by itself. Okay, that way we can figure out what that variable is actually equal to. For instance, if I have 5 equals w minus 2, we want to get this guy by himself. What we need to do is move the number, this guy, to the other side. Okay, we have to move it to the other side of this equal sign. In order to do that, we have to apply the inverse operation. Okay, we have to apply the inverse operation. Well, what's the inverse of subtraction? Addition. If I add 2, these two are now opposites. Don't they cancel each other out? Well, yeah. Okay. A negative or a minus 2 plus 2, isn't that just 0? It cancels out. Well, now wait. Now, if I added 2 to this side, what do you think I have to do to this side? I have to add 2. And you say, well, why do I have to do that, Mr. Pinksterhouse? Well, based on our properties of equality, we said if I add the same thing, the same number to each side, then I maintain an equivalent equation. In other words, I maintain equality. So in order to keep the equation equivalent, we have to add it to not just one side, but both sides. So keep this saying in mind. Whatever I do to one side, I have to do the other side. That's, in this case, we're applying the addition property of equality. Okay, so I'm going to add 2 to both sides, but we cancel out here. And then on this side, I have 5 plus 2, which is 7. Now, what remains on the right side? W. So what I end up with is 7 is equal to W. Well, let's check if that works. So in my original equation, I have 5 equals W minus 2. And we said W is equal to 7. Well, if I plug in a 7 here, is 7 minus 2 equal to 5? Well, yeah. So we know we're correct. 7 minus 2 is 5, so W equals 7. Okay? So let's go on to this next one. Okay, again, I want to get the x, the variable, by itself. So we have to apply the inverse operations. I have subtraction by 7, so I need to move this number to the other side. Well, how am I going to be able to move it to the other side? By applying the inverse operations, okay? So the opposite of subtracting 7 is adding 7. And remember, if they're inverses of each other, they cancel each other out. And then also, based on our addition property of equality, whatever I do to one side, I do to the other to maintain equality, I also have to add 7 here. So I have to add 7 to both sides. So this guy went away, and I get x is equal to, go back to when we talked about integers, different sign, subtract, 7 minus 6 is 1, and keep the sign of the larger. In this case, 7 is bigger and positive. So my answer is positive. So I get x is equal to 1. Now check, if I plug in 1 for x, is that correct? Well, in our original equation, we had x minus 7. If I plug in 1 into x, I get 1 minus 7 equals a negative 6. Is that true? Well, yeah. Different sign, subtract, 7 minus 1 is 6. 7 is bigger and negative, so my answer would be negative 6. Okay, so x equals 1, going back here, x equals 1, that would be our answer. And same thing over here, 7 equals w, that's our answer. Okay, now let's move on to these guys. Okay, so again, I want to get the variable by itself. That means I need to move this number to the other side. Well, how do we do that? Inverse operations. Okay, so what's the opposite of adding 2? Subtract 2. But again, whatever I do to one side, I have to do to the other. In this case, we're applying the subtraction property of equality. I can subtract the same thing from both sides. So it cancels out here, and I get 9 minus 2 is 7. Okay, so we end up with 7 is equal to y. Well, is that true? If I plug in 7, is 7 plus 2 equal to 9? Yeah, so this is a true statement, 7 is equal to y. Next example, again, I need to get x by itself, so I have to apply the inverse operations and move this number to the other side. What's the opposite of adding 8? Subtracting 8. But if I subtract 8, I need to apply the subtraction property of equality and subtract 8 from both sides. Okay, so we have our inverse operation here. It goes away and I get x. Now, same sign, remember integers, same sign, add and keep. 12 plus 8 is 20, and they're both negative, so my answer is negative. So I get x is equal to a negative 20. Well, check if that's correct. If I plug 20 back in, or excuse me, negative 20 back in, do I get a negative 12? Well, yeah, a negative 20 plus 8, different sign, subtract, 20 minus 8 is 12. 20 is bigger and negative, so the answer would be negative 12. Okay, so x equals a negative 20 would be my answer. Next one, we have 6 times x equals 18. So anytime you see a number attached to a variable, that implies multiplication, okay? That implies multiplication. Well, what's the opposite of multiplying? Dividing, right? So we said the inverse of multiplying is to divide. So if I divide the 6 to move it to the other side, I now have to apply the division property of equality, which says I can divide the same number to each side. Okay, I can divide the same number to each side. Well, what happens when I do the inverse? Well, the inverse cancels this guy out, and I'm left with x equals 18 divided by 6 is 3. Okay, so let's double check to make sure this is right. If I plug this back into the original equation, which was 6x, now it's 6 times 3. Is 6 times 3 equal to 18? Yes. So this would be my answer. Okay, next one. I have 21 equals 3w. I need to get the variable by itself and move the 3 over. Well, remember, if we have a number next to a letter, what does that mean? Or a variable, what does that mean? Multiplication. What's the opposite of multiplication? Divide. So I'm going to divide by 3. But if I divide by 3 to one side, I need to apply the division property of equality and divide by 3 to both sides. Okay, so my inverses cancel out, and I get 21 over 3 is 7 equals w. Well, check it to see if this is right. If I plug 7 back in, what's 3 times 7? 21. So we are correct, and 7 equals w is our answer. Okay, last two examples here. Now I have, I'm starting out with a fraction, which a fraction implies division. And I have x over 7 equals a negative 4. Well, what's the opposite of dividing by 7? Multiplying by 7, right? So if I multiply by 7, these two are inverses of each other. They would cancel each other out. However, I now have to apply the multiplication property of equality, which says I can multiply the same number to both sides, okay? So I don't want to just multiply 7 to that side. I also have to multiply it to this side. So my inverses cancel out, and I get x is equal to a negative times a positive is a negative. 4 times 7 is 28. Okay? Check, is a negative 28 divided by 7 a negative 4? Yes, a negative divided by a positive is negative, and 28 divided by 7 is 4. Last one here, I have 11 is equal to w over 5. I need to get the variable by itself. How do you undo division? multiplication. So I'm going to multiply by 5 to cancel out this inverse here. If I multiply to one side, I also have to do it to the other side. Multiplication property of equality. 5 times 11 is 55 equals W. So check, is 55 divided by 5 equal to 11? Yes. So this would be my answer.